So the first thing that we're going to be looking at under the topic of like the function in the brain, localization of function, that first topic in Unit 3 is actually the divisions of the nervous system. So kind of getting an idea of like the anatomy and the structure so that we can better understand the function and how it works. So the nervous system in the body is all about decisions and communications. The nervous system is one of the systems in the body that really runs our body. It receives information from the external environment, it processes that information, and then it sends out a decision. And as we can see in this diagram here, the nervous system actually has two subdivisions, the peripheral nervous system and the central nervous system. So the central nervous system is comprised of the brain and the spinal cord, and it's mainly involved in decision making, and it controls the body by receiving information from the peripheral nervous system, processing that information and sending back a decision. The brain integrates information and makes decisions, and it does that for both voluntary and involuntary functions. So for example, voluntary, like choosing to move a limb, but also involuntary decisions, such as whether to speed up or slow down your heart rate, something that we don't actually consciously control, but our nervous system still has a large role in controlling. And then the spinal cord is also involved in both decisions and communications. So for example, sensory information that's collected from like touch, for example, in your fingers. It might be collected in your fingers, sent to the spinal cord, and then that information is sent to the brain. And then if the brain wants to make a decision with that information, the brain will send that information or that message back by the spinal cord, and then back out to the hand. So you can see how it's involved in that like communication between the body and the brain. But the spinal cord can actually also make decisions by itself, which is what's called the spinal reflex, which is where the spinal cord chooses to make that decision of its own accord. Another really important clarification that I actually see a lot of mistakes about is the difference between the spine and the spinal cord. So if you're asked about the divisions of the central nervous system, it's really important that you say the brain and the spinal cord, because the spine is actually incorrect, because that's the bone that encompasses it. So just like the skull covers and protects the brain, the spine is like the bone column that actually protects the spinal cord, which is that bundle of nerves that's a part of the central nervous system that's involved in that decisions and communications. So like we said before, the spinal cord passes sensory information between the peripheral nervous system and the brain. It also makes those quick decisions and sends directives around the body. So again, coming back to that idea of communication and decisions. And then again, the idea that the spinal reflexes are those quick decisions that it's really easy for the spinal cord to make. For example, like a dangerous situation, like if I put my hand on like a hot plate by accident, my spinal cord doesn't even need to consult the brain first. It just knows automatically that I need to take my hand back because that's dangerous, and it's actually important for my safety that I really, really quickly make that decision. And then what actually is the peripheral nervous system? Well, that is everything else. So all of the nerves in our arms and legs, everything a part of the nervous system that's not the brain and spinal cord. So that's all over our body, sending those messages, receiving that information and all of that. And it actually has multiple subdivisions. So we have the autonomic and the somatic nervous system. So first, the autonomic nervous system. That's the nervous system that interacts with more of our internal body, such as like our organs. So receiving like stimuli and information from our organs, and also sending back messages to our organs. And then the somatic nervous system, which is more under voluntary control. It's more about like the interactions with the external environment and more about like our muscles, for example. So me consciously choosing to move my hand, that's more of like the somatic nervous system, because it's like my muscles are involved in it. It's about my interactions with the external environment, and it's under voluntary control. And like we covered before, it's still about that communication between the central nervous system and the body. And then the somatic nervous system communicates between the central nervous system and the voluntary conscious functions. So like what we just covered there. So for example, kicking a ball, moving your arm, all of that, interacting with the external environment. And then our autonomic nervous system, so that system that more interacts with the internal environment and controls those like automatic functions such as your heartbeat, that can also be further broken down into the sympathetic and parasympathetic divisions. So the sympathetic is mainly the emergency system that's activated when we feel threatened. So when you hear sympathetic nervous system, we're thinking fight or flight. Whereas our parasympathetic nervous system is our rest and digest. That's our normal day-to-day system that facilitates bodily functions like digestion. It also can like contribute to emergency responses such as like the freeze response, but it's mainly thought of as a non-emergency system. So sympathetic, think fight or flight, and parasympathetic, think rest and digest. And this here is just a little bit of like a visual of how the nervous system is broken down. So for example, the central nervous system, again, we can see is like in yellow here, it's like the brain and the spinal cord, and then the peripheral nervous system branches all over the body and is responsible for all of those other areas. Another example, just to illustrate here, we have an example of a dog that's in the snow, and we're going to having just like a quick think about what are the different roles of, for example, the autonomic and the somatic nervous system in this scenario. So for example, this dog's autonomic nervous system would be responsible for controlling its involuntary functions. So it's in the snow, but all of the regular functions are still happening. So for example, a dog's heartbeat is still being controlled by the autonomic nervous system. And the somatic system, which what we talked about was that voluntary control, that interaction with the external environment, that like more voluntary movement would, for example, be controlling the fact that the dog is actually choosing to walk. So that's like a semi-conscious movement of moving those voluntary muscles and again interacting with the environment in that way. So that's just another illustration of the difference between the autonomic and the somatic nervous systems. So we have another example here of the difference between the sympathetic and the parasympathetic nervous system. So for example, sympathetic nervous system, again, that is our fight or flight system. It's our emergency system. So what that does is when that's activated, it speeds up the heart rate, it ensures that more oxygen can be delivered to the body and the tissues. There's more glucose available for the body to use. It's all about mobilizing the body for action, and it's often in the presence of danger. So for example, here we have some very serious like athletes like riding their bikes. They're in like a high energy demands physical situation. So it makes sense that they're going to need an increased heart rate so they can deliver more oxygen, get more glucose so that their body can be ready for action. Another example that I think of with like a sympathetic nervous system is like when you're in a sense of like danger or you're being threatened. So if it's like a bear or a dog or something, that nervous system is going to be very like active because it's about mobilizing your body to act. Your body needs to be ready to run, which is where these changes come in really, really helpful. And then our parasympathetic nervous system is our rest and digest, our everyday system, bodily functions like digestion, like respiratory rate when it's just like regular, all of those things that just need to happen even when we're not in emergency situations. So for example, even just relaxing after a big lunch on the beach. So here's another illustration of like how our nervous system is broken up. So again, bringing it back to that main idea that the nervous system is all about decisions and communications. So receptors detect stimuli. So that could be something from the internal or the external environment. Stimuli is that information that we're detecting that helps inform the decision that our body is going to make. And then our sensory neurons communicate this information to the central nervous system. So it takes it to the brain, it takes it first to the spine, which then communicates it to the brain, unless it's a really easy, quick spinal reflex decision that it can make, of in which case the spinal cord can actually make that decision itself. And then once, I'll just pull up my laser pointer here. So we have our stimulus. Sensory neurons communicate that information to the CNS, the central nervous system. And then our motor neurons actually communicate like the directive, the decision, or the message about what are we actually going to do in response to this stimulus. And that's communicated to the effectors, which is normally like think muscles, glands, organs, the parts of our body that are actually going to help bring about a response. So whereas, for example, in a reflex arc, we actually only have this pathway. And then as the interneurons in the spinal cord are making the decision, so like, right, you're in danger, you need to take your hand off this hot plate, it sends that decision to the effectors. It's like saying, I know this is an easy decision, so I'm going to make that to save time so that it can help the organism survive. And then it also sends that information to the brain. So by the time I've already removed my hand from the hot plate, I've already made the decision to keep myself safe. Whereas in regular like neuronal communication, we do have that information coming, and then it goes from the spinal cord to the brain. The brain makes the decision because that's where we do all of our thinking and our higher order like processes. And obviously the brain is quite specialized in a lot of regions. And then once the brain makes that decision, it sends it to the interneurons, and then from there it communicates it to the effectors.